Hi. Just thought I'd give you an example of one of the odd number problems. I'll look at number 3. Um, Now you can use this, the visualization tool to do your homework. You can draw them out, whichever case may be. But let's take a look at number 3. Now, in this case, you've got a sequenced list of data, which is different than your homework assignment number 2. But uh, what do you think the results of a sequenced list is going to be, or a sorted list, as far as a binary tree? So knowing that what a definition of a binary tree is, where you've only got 2 branches, binary 2, and the anything to the that is less than the node you're investigating, you add it to the what? You add it to the left. Anything greater than, you add it to the right. So you can just, if you think through it, you'll find that you're going to get an unusual binary search tree, which probably is not going to speed up the search for a particular element. So let's just see what what number 3 has. So let's start. It says insert number 7. That was easy. Now it says let's do number 10. Insert 10. It compared. Let me slow that animation down so you can see how it's being added, what decisions are being made. So we look at the next one. It's 14. Insert that one. So I'm looking at the subtree. I'm comparing based on if it's greater than or equal to. Let me slow that down just a touch more so you can kind of read what that is. Let's go to 23. Insert that. So I'm comparing, looking at the right subtree. It's greater, because all the things I'm looking at greater than or equal to. If it's greater than or equal to, it's getting added to the right subtree. So you can kind of see where this is going, can't you? Yeah, I'm going to insert that one. Let me, now that you understand what the sequence is, let's speed it up a little bit. It says now it's 33, and now it's 56. 1, 2, everything's greater than, so everything's going to that right branch. 66. I'm going to speed that up some more there too. Okay, speed it up. Okay, it's got to wait for its cycle. So after 66, you got 70. Well, so much for the speed up. But all it's doing is making the comparison. If it's greater, it goes to the right subtree. If it's less than, it goes to the left. And of course, you know where 80 is going to go. So if you had to search for, let's say you had to search for the element 80, how many different nodes would you have to go through? So in this case, if you have a sorted list, in this case, you'd have to go through every one of those, what do we got there? 8 different nodes. You'd have to go through, it looks like 9 nodes to find the one you're looking for. So sometimes the way data is presented to you may dictate which kind of data structure you want to use. There are others out there that we'll talk about later as far as better ways of organizing data. But let's take a look at a couple of events. Let's see if we can clean up. Let's go back. Let's step back and get rid of all these here. And let's kind of, all right, I'll even do your homework for you. This way you'll see how many people actually watch the videos. So let's look at number 2. It says, I got number 14. Let's go to 23. And you see, what am I doing? I'm making a comparison based on the size. In this case, it's greater than. Now I'm going 7. Now 7 is going to be less than. Now it's going to compare the top node. It says, is it go to the left or the right? Now it's going to be less than. It goes to the right. Now I'm going to do 10. So I'm going to compare 14, decide if it's greater than or equal to, it's less than, make that comparison on the second node, number 7, and insert it there. So as each node, it's making the comparison as to which one. So here's 33. So here it's greater than 23, so it should go on to that right node. And here we've got 33, 56. Where do you think that one should go? Should go to the right side of 33. So once you made a decision, if it's greater than or equal to 56, 80, again, what is it going to do? All the way down that right side. Oops, I guess I goofed that. Let me back that one off because, well, 56, 80. Yeah, I'm right. Okay. 80. Now I got 66. Now, at what point do you think this one's going to change directions? So it's still greater than, go down the right side. Now it compares to 80. It says, oops, it's less than. So at that point, it gets to that left branch there. And then the last item is 70. And where do you think this one's going to go? It's going to be less than the 80 branch, so it should go off to the left-hand side there. And then when it compares to 66, it should do what? It should go to the right. Let's see if we're close. As you can tell, there's 80, it's less than, goes to the right-hand side, left-hand side, I guess depends on when you're looking at it, and it goes to that. So this is how you would do, this should be your answer to number 2. Now, what happens if I'm actually searching for, if I'm searching for, let's say I'm finding 56. So let's see what it does for finding 56. So I compare 14, it's greater than, and I've eliminated that whole right branch or that whole left branch, but I'm looking at it, because 56 was greater than 14. So it's always making the comparison, and it says, okay, is it greater than or equal to, and I can prune or not search half the data. Now here you definitely have an unbalanced binary tree, and there's algorithms we'll talk about later, the benefits of having balanced trees, because what you want to do, you're creating a search, you want to optimize, you want to make your searches faster. So sometimes the data representation using a certain data structure may not be beneficial. So hopefully this video helps a little bit, that you can get comfortable with the binary search tree, how it operates. And if you have any questions, let me know. Talk to you later. Bye-bye.